Welcome to the third in our SenixVIEW video tutorial series, Basic Sensor Configuration. We return to the main workspace window, and in this case we're going to click on the measure icon on the toolbar. This brings up the measurements window where we set basic sensor configuration. Measurement activation has a number of choices. Continuous is where it's generally left, although start on pole is sometimes used. The suite of synchronization choices we'll revisit in a special section. Let's leave it on continuous. Power save is disabled, and that is the normal mode of operation. The sensors don't require a great deal of power, and only in a battery-operated, power-starved situation would we consider the enabling power save. Measurement interval is at default, or 50 milliseconds. That's 20 readings a second. For illustration, let's change that and slow it down to 100 milliseconds. That's 10 readings a second. Temperature compensation is set at none by default. We'll make that be internal, and now we're going to use an internal temperature sensor within the body of our distance sensor to track changes in the measurement environment. To the right in the sensitivity box, you'll see gain profile, and this can be set to any one of 6 basic settings: free air, low, medium, and high, and stilling tube, low, medium, and high. We'll leave it in free air medium for now, which is the default. But in a stilling tube environment, it's necessary, because the sound is contained within the tube, to reduce the gain, and that enables operation in that case. In extreme cases, we may need to go to advanced, and in advanced gain settings, we're able to see the change in sensitivity with time or distance for each of the standard settings and make some adjustments to them. I don't recommend you do that unless there's a specific reason, and we'll revisit this in certain application sections. So let's leave that for now. I'd like to call your attention to the filter options. This is the onboard signal processing capability. We have the ability to put an input rejection filter in place. It can be one of 3: X of Y samples, which I'll explain in a moment, the furthest of samples, or the closest of samples. Closest of samples might have any one of a number of readings in there. If you put in 10, it would return to you the shortest reading amongst the last 10 that were made. In the case of furthest, it would be the same. You might be able to see that those two could be used to pick the peak of a wave or trough of a wave. The X of Y samples is a little more complicated. The default is typically 3 out of 4, but I like to use 2 out of 2. What it does is apply a 12% arbitrary filter. It falls out of the digital math, but when you set 2 of 2, what it says is only output a measurement if 2 measurements in a row are within 12% of each other, the 12% being arbitrary. And that eliminates any strange reflections or hiccups that you might have with the sensor, and sometimes ultrasonic transducers do tend to hiccup. Not often, but this will filter out any of that. I like to use it at 2 of 2, and usually it has no impact on what you're doing, except in some cases in tanks where it may. Signal averaging is of particular interest. Here you can choose none, or a running average, or a boxcar average. Running average gives you the mean of a number of samples. Default actually is 2 here. You get a signal-to-noise improvement that is proportional to the square root of the number of samples. So a sample of 10, square root is a little over 3. It'll be about a 3-time improvement in signal-to-noise. If I put in 100, it will be a 10-time improvement in signal-to-noise. But it obviously takes more readings to get there. So if we were, for example, measuring 10 times a second, and we said, give me the average of 10 samples, we would have the mean of 10 every second. In the case of a running average, it will bring in the latest reading, give you the average of 10, throw out the oldest. bring in the latest reading, throw out the oldest, give you the average of 10. And that's, so that would be a 1 second mean output 10 times a second. If you did it as a boxcar average, it will not output until it's taken in 10 samples, and it'll give you the mean. It'll take in 10 and then give you the mean. So the running average is a little bit more responsive to change in the measurement environment, but it does impose something of a low-pass filter on your data. I'm going to leave it at running average. Often, by the way, I will set this to 1 second interval and samples to 60, so I have a minute's worth of data every second. Distance limiting has a couple of possibilities. Slow-fast is one filter, and rate of change is another. They're both generally related to machine control applications, and we'll deal with those a bit later. They're not used very frequently. So we'll leave that at none. Let's OK out of this window. And now you'll notice that we have a not equal sign between the workspace and the sensor. What we have to do is download to the firmware the changes we've made in the workspace. Two ways to do that. Sensor menu, come down to Move Workspace to Sensor. And you notice the pencil will write to the right. Alternately, you can right-click on the workspace icon, see the other pencil come up, and we can just drag it to the sensor and release it. It achieves the same thing. So those are some of the basics in sensor configuration. In our next session, we'll discuss the configuration of our analog outputs and show you some of the test facilities that are present in the program for verifying your house wiring in terms of analog outputs.